What if I told you that right now, as you sit reading or listening, a network of tubes over 60,000 miles long is working non-stop inside you? It wraps every corner of your body. It feeds every single cell that makes you you. That length is longer than twice the entire circumference of the Earth. This hidden, constantly moving network is your circulatory system. You never think about it. You never feel it working. But if it stops working for even a few minutes, you're gone. No exceptions. Every cell in your body depends on it. Cut off its flow, and the lights go out fast. Today, we're breaking down exactly how this incredible system works. We'll cover how your heart keeps the beat, how blood carries oxygen to every corner of your body, and why even a small blockage can turn deadly in minutes. This is your complete, no-jargon guide to how the most vital system in your body keeps you alive. Let's start with the basics, and build up to the problems that can shut the whole thing down. Let's start with the engine that drives the whole system, your heart. It's not just a romantic symbol printed on greeting cards. It's a hard-working muscle that beats non-stop, 24 hours a day, every day of your life. It beats 100,000 times every single day. That adds up to 35 million beats a year. And most of the time, you never even notice it working. Now let's break down how it's built to handle that endless workload. Your heart is split into 4 completely separate chambers, 2 stacked on each side. The 2 upper chambers are called atria. They receive blood coming back to the heart from the rest of your body or lungs. The 2 lower chambers are called ventricles. They do the hard work of pushing blood back out, away from the heart. Between every pair of connected chambers are special valves. These valves act exactly like one-way doors. They swing open to let blood flow forward into the next chamber. Then they snap shut tight to stop any blood from sliding backward. That closing motion is what creates the sound you know as a heartbeat. When you press a stethoscope to someone's chest, the distinct lub-dub you hear is just these valves slamming closed one after another, every single beat. Now that we understand how the heart's chambers and valves work, let's walk through a full cycle of blood flow, step by step, from start to finish. First, blood that has already delivered most of its oxygen to your body's cells comes back to the heart. It returns through 2 large veins called the vena cava and empties directly into the right atrium. The right atrium contracts right on schedule, pushes that oxygen-poor blood through the open tricuspid valve and into the right ventricle below. The valve snaps shut behind the blood, so it can't leak back. Then the right ventricle contracts hard, pushes the blood through the pulmonary valve, and sends it out straight to your lungs. That first leg of the journey is called the pulmonary circuit. When the blood reaches your lungs, it drops off all the carbon dioxide waste your cells produced. Then it picks up a fresh, full load of new oxygen. Now, this oxygen-rich blood travels back to the heart and empties into the left atrium. The left side of the heart takes over from here. The left atrium contracts, pushes the oxygen-rich blood through the mitral valve and into the left ventricle below. The left ventricle is the strongest chamber of your entire heart, and for good reason. It doesn't just send blood a short distance to your lungs. It has to push blood out to every part of your body. It has to reach the tip of your brain, and the tips of your toes, and every cell in between. It contracts harder than any other chamber, pushes blood through the aortic valve, and into the largest artery in your body, the aorta. From the aorta, blood branches off into smaller and smaller tubes until it reaches the tiny capillaries that wrap around every cell. That's where it drops off its oxygen and nutrients, and the whole cycle is ready to begin again. Most people know we have 2 types of blood vessels, but few understand how different they really are. Each is built specifically for the job it does, matching the pressure and flow of blood passing through it. Let's break them down in order, starting from the heart. The first type is arteries. Arteries carry blood away from the heart, and almost all of them carry oxygen-rich blood. Blood is pumped directly out of the heart at high pressure, so arteries need thick, muscular, elastic walls to handle that constant force. When you check your pulse by pressing your fingers to your wrist or neck, what you're feeling is an artery expanding with every heartbeat to absorb that pressure surge. As arteries get further from the heart, they branch into smaller and smaller versions. The smallest are called arterioles. From arterioles, blood moves into the tiniest vessels of all, capillaries. Capillaries are so small that red blood cells have to line up single file just to pass through. Their walls are only one cell thick. That thinness is exactly what lets oxygen and nutrients move out of the blood into your surrounding cells, and lets carbon dioxide waste move back into the blood to be carried away. Once blood has dropped off its oxygen and picked up waste, it moves out of the capillaries into small veins called venules, which merge into larger veins that carry it all the way back to the heart. Veins work with much lower blood pressure, so their walls are far thinner than arteries. But they have one special trick arteries don't: tiny one-way valves inside them. These valves snap shut after blood passes through to keep it moving upward against gravity, especially in your legs. When those valves weaken and stop working properly, blood pools in the lower legs, and you get varicose veins, the bulging, twisted veins visible under the skin that affect millions of people. We've covered the pump and the pipes. Now let's answer a question most people can't explain. What actually is blood, anyway? It's not just red liquid that comes out when you get cut. It's a living tissue made of 4 distinct key parts, each with its own critical job. Let's break them down one by one. First is plasma. This is the yellowish liquid part that makes up more than half of your total blood volume. It acts as the carrier, moving nutrients, hormones, and waste products to where they need to go around your body. Next are red blood cells. Their entire job is to carry oxygen. They use a special protein called hemoglobin that binds directly to oxygen molecules, and that hemoglobin is what gives blood its bright red color. Right now, you have about 25 trillion red blood cells circulating through your system. Third are white blood cells. These are your immune system's frontline soldiers. They hunt down and destroy bacteria, viruses, and any foreign invaders that get into your bloodstream. Last are platelets. These are tiny cell fragments that handle clotting. If you cut yourself, platelets rush straight to the cut site, stick together to form a plug, and seal the hole so you don't bleed out. Now that we know what makes up blood, let's answer another common question. How does your heart know when to beat, and how does it adjust when you need more oxygen? You don't have to think about making it beat, right? That's because of a tiny group of specialized cells called the sinoatrial node, or SA node for short. It sits right inside the wall of your right atrium. The SA node sends out a steady electrical signal that spreads across both atria first, making them contract to push blood into the ventricles. The signal pauses for a split second to let the ventricles fill completely, then passes through the atrioventricular node and spreads across both ventricles, making them contract to push blood out. That whole sequence creates one full heartbeat. The SA node adjusts your heart rate automatically, second by second, to match what your body needs. If you're running upstairs, it speeds up to get more oxygen to your working muscles. If you're sleeping, it slows down to save energy. It never stops adjusting, even when you don't notice it working. Every part of this system works in perfect sync, day after day, year after year. Without you ever noticing, it's there. But when something goes wrong, the damage builds slowly, silently, until it suddenly stops the entire cycle cold. Let's break down the most common problems that can throw this perfectly tuned system off. The first and most deadly is atherosclerosis. This is a slow, gradual process that plays out over decades inside your artery walls. It starts when plaque, a sticky mix of cholesterol, fat, and calcium, starts to build up on the inner lining of your arteries. At first, there's no symptom, no pain, no warning sign the process has even started. The plaque gets bigger and harder over time, slowly narrowing the space inside the artery where blood can flow. This cuts down on the amount of oxygen-rich blood that can get through to your cells. But the damage doesn't stop there. Even this slow narrowing isn't the biggest immediate danger. There's a second common problem that's even more insidious, because it can kill you without you ever knowing you have it. That's high blood pressure or hypertension. Blood pressure is just the force of your blood pushing constantly against the walls of your arteries. If that force stays consistently higher than it should, it puts extra constant strain on your heart and every blood vessel in your body. Over years of this extra strain, your risk of sudden catastrophic failure skyrockets. The most terrifying fact about high blood pressure? Most people who have it have zero symptoms. You can live with it for 10, 15, even 20 years and never feel a thing, while the damage builds steadily every single day. That's why regular blood pressure checks are one of the most important preventive steps you can take for your long-term health. This hidden, gradual damage doesn't stay hidden forever. Eventually, it triggers an event that can kill you in minutes. That event starts with the plaque that has been building for decades. When the inner lining of the plaque tears or ruptures, your body reacts just like it would to any cut. It sends platelets rushing to the site to form a clot. That clot forms right on top of the already narrowed artery. In minutes, it can block 100% of the space inside the vessel, cutting off all blood flow downstream. This can happen anywhere in the body, but it's deadliest when it hits two critical locations. First, the coronary arteries. These are the small arteries that feed oxygen-rich blood directly to your heart muscle itself. When one gets completely blocked, the section of heart muscle downstream stops getting oxygen. It starts to die within minutes. That's a heart attack. Without immediate medical intervention to open the blocked artery, the damage can become permanent and kill you fast. The second critical location is the arteries that feed blood to your brain. If a clot blocks flow to a section of your brain, that area of brain tissue dies in minutes. That's a stroke. Strokes can kill instantly, or leave permanent disability if the person survives even a short window without oxygen. This is why heart disease is the leading cause of death across the entire world. It takes a system you never think about, slowly narrows the pipes over decades, and then triggers a sudden, complete blockage that can end your life before you even realize what's happening. The cycle your body relies on every second of every day stops cold, and there's no backup. Beyond the sudden blockages caused by atherosclerosis, there is another widespread, deadly condition that works silently in the background for years. High blood pressure, or hypertension. Let's break down exactly what it does, and why it's so dangerous when it goes undetected. Your blood pressure is a measurement of the constant force your blood exerts against the inner walls of your arteries every single time your heart beats. When this pressure stays consistently higher than the healthy range, it doesn't just stop there. It adds constant extra strain to every part of your circulatory system. Your heart has to work harder with every beat to push blood out through your body. The walls of your arteries take constant, repeated abuse that damages their inner lining over time. This damage speeds up the buildup of atherosclerosis we just talked about and creates new risks of its own. Over years of sustained high pressure, your risk of sudden heart attack and stroke doesn't just go up a little, it skyrockets. It also doubles your risk of chronic kidney disease, because the tiny capillaries that filter your blood can't stand the constant extra force. It can even damage the blood vessels in your eyes, leading to gradual vision loss over time. The most terrifying part is what you won't feel. Most people with high blood pressure have zero obvious symptoms. You can walk around with elevated pressure for 5, 10, even 15 years, feel completely fine and never suspect a thing, while the damage builds steadily day after day. This isn't a problem that only affects older people. More and more young adults in their 20s and 30s are developing high blood pressure from lifestyle factors, and most of them don't know they have it. It doesn't cause a headache. It doesn't make you feel short of breath, not until the damage is already severe enough to trigger a catastrophic event. That's why getting your blood pressure checked regularly, even when you feel perfectly healthy, is one of the most critical preventive health steps you can take. It's the only way to catch this silent killer before it causes permanent, life-threatening damage. Let's wrap this up with a quick, clear recap to lock in the full picture of how your circulatory system works. The entire network runs on two connected, overlapping loops that never stop turning. The first is the pulmonary loop. This loop carries oxygen-poor blood out from the right side of your heart, straight to your lungs. In your lungs, the blood drops off the carbon dioxide waste your cells produced and picks up a fresh load of oxygen. That newly oxygen-rich blood then flows back to the left side of your heart to start the second loop. The second loop is the systemic loop. This is the big one that reaches every corner of your body. The left side of your heart pumps that oxygen-rich blood out through the aorta into arteries that branch smaller and smaller until they reach the tiny capillaries that sit right next to every cell in your body. There, the blood drops off oxygen and nutrients, picks up waste products, and flows back through veins to the right side of your heart to start the whole cycle over again. That makes your heart a specialized double pump. The right side is dedicated to the pulmonary loop, sending blood to the lungs. The left side, with its stronger left ventricle, is dedicated to the systemic loop, sending blood out to every part of you. This is the cycle that keeps you alive. It doesn't stop when you sleep. It doesn't pause when you eat, or work, or relax. It started beating and pumping before you were even born. and it will keep running non-stop until your very last breath. If you learned something new about how your own body works today, hit the like button to help more people find this guide. Subscribe to our channel for more simple, clear explanations of how your body's systems work, broken down step by step without confusing jargon. Leave any question you still have about the circulatory system in the comments below. We read every comment, and we'll answer your question in our next video.